Right, you guys. Let's do last one of the week. Chapter 14 exercise. Just an introduction to sheet metal, just a real quick down and dirty. I'll try to keep my explanations to a minimum, but you know me, Mr. Over-explainer here. Let's see. Chapter 14 exercise is just going to be following this book. There is a video you could follow him step by step. So it's just a great introduction to what's going on, what I see in a sheet metal part, which we will then start to use a lot more frequently. So let's just step into this. I'm just going to follow along with my book. Maybe I better open my so I can see if I'm going off course. But yeah. Okay, good. Haircut weekend for sure. And it's nobody's fault but mine. My wife has offered several times. I have been the problem. I will no longer be the problem this weekend, unless I'm going to go long. Maybe long. I've worn a long goatee before. Kind of starting to feel that way again. Let's see. No, it's winter still, so let's do this. So I'm just following along. Of course, I don't have a lot of imagery up for this. I'm just following along with the book, but I'll call out what I'm doing. So it's going to be a sheet metal part, inches units on this. So we're going to do a new get out of that metric folder for this time around and go back to the English folder. And we're going to do a sheet metal part, which doesn't matter which one I choose because they're interchangeably in them. But let's just start it with a sheet metal part. Create it. Has a different ribbon menu or a different tab. Has a sheet metal tab unique to sheet metal parts. And here's my 3D model tab, and you can quickly convert back to a standard part here, and you would drop that tab and just kind of have your what we've been using so far. So sheet metal tab, again, and really in the book it doesn't go into explain too much in detail. Usually when I get into a sheet metal part, the first thing I'm going to do is kind of set up the sheet metal defaults and establish a thickness because it's a little bit unique in that what I'm really creating is a sheet metal part, so that's going to be driven by a thickness, and I can set all that up, and then you'll notice like on this particular tab, I can still like make sketches and do kind of the normal way I would start a part, 2D sketch, make a part, then go to the extrude to make it 3D. Well, they don't have extrude here, they have face because you're always going to set like a you're going to set a material thickness that you're working with here right off the get-go. And most companies will maybe just spend the time to build out their sheet metal defaults. And so they have like a selectable sheet metal size ready to go. And I can just like jump in here and select it. Right now, it's just going to use default 0.12 thickness. But in the event that I actually had and so we'll do this actually when we get into it. We'll establish some sheet metal sizes maybe, and one day I have in mind to make a comprehensive library for the parts I need and for some a lot of different things, content centers for standard parts, and anyway, I got some work to do myself to build a library for ISU, but I'll get there. One day we're just still using default generic. So, I mean, I can change this similar, but I just wanted to show you that this is normally where I would go and I would actually establish a sheet metal and not just use the default. But he doesn't change anything. I'm not changing anything. We're just going to use it as default inventor, but that's usually your go-to first. Anyway, we're actually going to go to a sketch. So I'm just going to do it on the X and Y plane. So I'll start my 2D sketch on this XY plane. The part we use for this is just rectangular, so I'm just gonna do a rectangle. Ends up being, I think he makes his 5 by 3. Simple little part. And I'm just gonna constrain mine in model space here. I mean, yeah, part space. Model space, part space, yes. Constrained 3 by 5. See, now it's just like I'm into the extrude phase, like I normally be in a 3D part, but I just select face because it's like, oh, I know I'm driving by those default thicknesses, so you don't have to. I'm doing like I'm following these rules that are set. So when you face this thing, it's driven by that thickness. Ours is just default. We haven't assigned. We're just using that 0.12 thickness. So that's it. And so this part, whether I put this sketch in between or not, I mean, we're dealing with a little bit thinner parts in sheet metal. Remember, from 1/4 inch under. And yeah, I mean, there's just overlap in plate and sheet metal. in those quarters to 10 gauge. They might have the 1/8 inch plate and 3/16 plate and 1/4 inch plate. So there's some overlap in plate to sheet metal. Sheet metal is going to be your most expensive, according to, but there are cheaper versions of sheet metal and more expensive versions of sheet metal. And why that is because some metal, when it's manufactured, has a mill scale on or kind of a flaky outer surface. If you've ever watched anybody like I mean, this is an extreme version. If you've ever watched anybody forge anything and they pull it out of the hot iron and they like pound it and all these flakes are flying off. Well, on the cheapest metal that we can probably purchase, whether it's sheet metal or plate, it's going to have some of that flaking residue on the outer surface, even though a lot of it's flaked off during just the handling, and I'm sure they have ways to clean that off at the end at the manufacturing plants. But then they also have ways to make sheet metal that doesn't have that. And cold rolled iron has like uh, a surface finish that is maybe more readily paintable, but it's going to cost you more money. So sheet metal comes in super variety of expenses, essentially. I mean, material types for sure. Even our own sheet metal chart has, it just shows stainless, galvanized steel, and aluminum. And so we definitely have different material types, but we also have just kind of different material finishes, and the cost is different for those. But yeah, so that's a little bit of a sheet metal entry. But this is just that profile. I'm not gonna really have a real hard specification on which way I'm facing this off or extruding it. So I'll just say yes, okay. So there's my part that he starts with is just a 3x5. And then what you have is, because sheet metal, the reason why we use it is so it's bendable. I can make a lot of shapes, and not all sheet metal is bendable, but so I have to be aware of that. But in this case, we're going to be using. We don't even determine the material type at all, so we're just going to assume that this can bend. But yeah, you have to be careful. Not all materials are bendable, and because there is stresses going on in a bend, and some materials are designed to accept those bends and not reduce the strength of the material. Others will crack out on you, and aluminum is what I'm thinking of. There's specific types of aluminum that bend really easily, and others just crack and are not bendable. So also, once you've bent metal, it's hard to undo that, and so it's pretty rare to like bend something wrong and then be able to unbend it, fold it flat, and then rebend it. Now you're going to break this stuff. So, you get kind of a one shot. Um, I call that the Eminem factor from the Eminem artist in the song from 8 Mile. I don't know. I can't remember what the name. I should know. You get one shot on sheet metal bending. Uh, it's not very, and some of it work hardens too. So different topics there, but. Let's put some, so what we're gonna do is we're gonna bend some flanges on here. And so what we do is, like, the most common thing that I might do with sheet metal is right next to facing and picking the thickness is actually bending, putting some flanges on this, like building a shoebox lid or something. This ends up being kind of a funky little thing that we build here, and I know nothing about it, so it's hard to make any calls on how I need to do this. But it's a flange, and I get this quite extensive dialog box. I have it fully expanded out so I can see every selection. But I mean, these are collapsible. All of these, this little menu gets collapsible. So definitely it just kind of works in order of priority down through these dialog boxes from top down. So if I just say, well, I'm selecting an edge to bend this on, there are some other geometry that I might be able to select and more specifically specify how I want to bend this flange. But what it's going to do is select an edge, and he just takes, maybe he's on his front view here, and he picks an edge like this because I can't, like, sheet metal has all these edges I can select. He just selects like one of the shorter sides and bends it. And this just shows you what's going on. Its defaults show up. So let me expand this next one, which is going to be its height or its distance. So right now, default is 1 inch, a 1 inch flange being applied to this edge here. And now I have kind of a selection of well, which direction's it going? Well, the reason why it chose to go this direction was based off the edge I selected. And I can reverse that, but normally I would try to select the right edge off the get-go. But it is reversible here if you pick the wrong one. I would just try to pick the right one and going in the direction I want to go. Because it doesn't necessarily change the edge selection. So it's kind of bending reverse kind of from this point, which could affect overall lengths and stuff. So I'm trying to think of, okay, I'm selecting this way to bend. And if I hesitate over here a minute, it shows me some dimensioning. If I kind of highlight around this thing or just kind of hover over it, it's like 1 inch. And this is what I call is like an OD, like a 1 inch OD flange. And I'm thinking of it as an outside dimension rather than outside diameter. But I use those terms probably mistakenly interchangeably. ID, inside diameter, OD, outside diameter. I also think of it as like inside dimension, outside dimension. This to me looks like an outside dimension. Like I'm kind of measuring from this side of my material to the end of the flange is 1 inch. And I can change that by this next. So that's because this one is from intersection of two outer faces. That's maybe what the default location for the measurement was going to be. This is the measurement. In ours, we actually changed this to two in the book. So he just changes that to two, and then if I changed it this way, we'll notice how that dimension pops different though. See, now I'm measuring from kind of an inside to the overall length is now going to be my 2 inch dimension that's holding. So what this does is it increases like one is going to be a shorter overall dimension than the other, like of necessary material to make that bend. And what we have going on is we have some compressive forces on the inside radius smashing that steel, and we have some stretching of materials around the outside radius. And so, I mean, that's what can break materials that aren't designed to do this. But is that those compressive forces and the material can't handle it, and then you have a bend that breaks. Um, and some materials that are bendable, some of the we can actually end up actually breaking them, and there's some relief cuts that we can do to kind of help prevent some of that breakage, even on bendable material. So anyway, but what we're dealing with is kind of the measurement, like where the measurement of the part. Is it OD? Is it ID that my 2 inch flange? Usually this matters. This definitely matters. Like there's generally a reason why one is going to be the other. And but what I want you to say is if I unfolded this like origami straight, one is going to be a longer amount of material needed to make that bend and meet those dimensions, and the other one might be a different length. So this kind of affects overall part length. And when I think of sheet metal, I do think of origami, and I think of the fact of like folding, a 2D shape or something, a flat profile into a 3D profile in some ways, and which we do with origami as well, right? And so those bends and those overall lengths and these stretch outs, these flat patterns, they kind of are affected by my selection and how I want these to bend and what dimension I'm really truly looking for to finish with. And this affects potentially just the overall flange length. And so what do I got here? I've got maybe from selected edge. So now it's going to be 2 inches from that inside edge. It seems very similar to this one. Like you can't see that this change, the dimension doesn't change, nor does it seem like it changes pulls from the inside on both. But I think it's going to affect a slight adjustment to the overall like part size, the difference between these two, even if they look like they're pulling from the same point. I think we'd see some difference when I measure the flat pattern, and you'll get to see what I mean in just a minute. And then this one is one from tangent plane. So it seems like it's pulling from the OD, and it might be, but I think it's just, I mean, these are micro measurements that would be a little bit different. And really, I might find that my machine responds better. So why this is kind of an extensive dialog box to dig through. So it's almost a little bit overcomplicated in order to learn it. But the reason is because it's really set up to everybody's bending equipment is slightly different, even probably if it's the same machine um, delivered to two different manufacturers, the way they set it up, whatever. There's some effects on this that could be, I need micro adjustments in order to match what my machine produces, like what I anticipate from a design. And this is how, like, manufacturers have to do this. If they get a new machine and they have like, they're running this program, they may have to like just kick out a few part strips to go bend and decide like how it's responding to these materials. I mean, modern machines are very programmable beyond what even the part size I deliver from them, but not necessarily. I mean, once I've had the machine cut from my part file, they're going to be like they're not. There's only going to be so much they can do on the end to bend it to make it match the dimensions that I'm requiring. So, I mean, this is a little bit of a deep study. I don't want to go too crazy too in the weeds, but these things matter. And I think he sticks with just this, like an OD bend. Well, I don't know. Let me look. Oh, outside diameter band. Let me just see if I flip through. I think he starts doing this on kind of page 14.7. Looks like he's, yeah, sticking to the outside profile. I do think even if we match his exact settings, we end up with a little bit, students have shown me they end up with a little bit different measurement than he shows in the book. And I'm not critical on that. I really have to fine tune what my settings are different because every box I expand here gets pretty extensive, right? So that's all I can select here on the heights extent. Like, which way am I pulling the dimension? Which way am I folding around and what's that length? And then I go down to this next dialog box and I even get more control over the angle and the placement and how that angle affects the length. This is additionally complicated, but he does a 60-degree bend first. So he doesn't bend a full 90 degrees. So that's like a 60-degree bend. It kind of shows this like reference plane that it's bending. And there's my reference dimension from straight 180 degrees, 60 degrees right there. So you have to know, like, it's every angle it matters, like where I'm pulling from and where I'm going to. Do I call this 60? Do I call this 30 off of 90? I don't know. It matters, but this I have to be aware of at least how the program is pulling that dimension. And then on top of that, I have these additional, kind of like I did here, I have some additional like placements of like where that plane may be, plane through partner edge is what I have here. Plane through partner edge. Maybe this is the partner edge and the plane goes through it. So what if I choose the next one over plane through selected edge? So that kind of shifts. This would absolutely have a different effect on how long this part is when it's flat. And based just off this is a pretty substantial like uh different placement in where I'm taking that 60-degree measurement and how long this part it becomes. So I think he stays with this one. Well, what's this one? This is maybe in between the two, or what is this one? Let me hover over it. Let me read it. Plane tangent to, or at a side face. So I'm tangent to, looking like this side face must be my yeah. It's different than both of them there, right? Yeah, definitely. In my experience, we found a cut. We once we understood our machines and how they bent, and maybe doing some additional kind of there's additional like these bend properties below me are going to get even more complicated. Once we made some of those adjustments, we found there was probably a couple of these selections that we wanted our drafters to use over and over because we had programmed our machine so that, or at least we had tested our machine to our inventor, like these measurements and placement, and we determined that this most closely matches what I'm expecting at the machine. And so these once we kind of dialed these in for our materials and our machine, it tended to be that we stuck with these measurements, which one I'm measuring with, which one I'm selecting here, and which one I'm selecting here, and even the position here. So there was a series of these that we always used that we had dialed into our machine. And I think most companies will do that too. Like, if they've dialed in the machine to be these measurements, this placement, this position with these bend properties, then if you change any of those, you're going to have some issues with what they're expecting on when they run the machine and get their bend profiles. And so let's see. So I think he chooses this one, and then he chooses the position. So let's see how the position changes and jumps around here. So if I jump, this is outer face. I think the default here that it's selected was outer face through plane. And what if I do like the inner face through plane? Definitely is going to definitely going to change that. Some of these changes look like they're doing the same thing, and so that can be kind of confusing on, well, what's the difference between this and this? Yeah, it can be hard to know unless I have a piece of equipment that I'm evaluating it against which combination is going to be. I think he does make a change here. If I see what he selects, I do think he selects the position to be this particular one, interface through plane. But even so, I think we end up with a different measurement than he does. So I don't know what else he's got going, but it's probably in this next series right here, bend properties. All right, so what do we got? We got a bend radius, which I think I can enter a dimension here, or it's just like it's like allowing me to change this, but I don't really have a drop down. So I could select anyway. I'm not going to change anything here. I'm going to leave it bend radius, unfold rule. So the way it folds, I'm following the default K factor, but a K factor is an adjustment that I can make. So, I mean, different materials might have different K factors. So I might have a series of K factors and I might set those K factors, which is weird, but it's going to be some like probably decimal input that I have, some kind of like a micro adjustment potentially that matches my equipment and how I'm expecting the bends to happen. I can set those K factors to go along with my sheet metal for, I might, because to test a piece of equipment, I'm not just going to grab one piece of sheet metal and say it's good. I may have to have a series of tests with different thicknesses and determine how does it bend 10 gauge? How does it bend 12 gauge? How does it bend 14 gauge? Maybe I don't have to do every size and there's some adjustment between them, but I may have to set this, and spend some. I feel like what's happened if a company is ready to roll on this, they've spent they've spent some engineering behind this, working with technicians, working with the equipment, and then building my program to match what my expectation is and what I'm getting out of my equipment. So there's definitely going to be, if people have dialed this in, they've spent time comparing it to equipment expectations. So I'm just going to leave it as default here. The relief shape. So the relief shape really is like it really matters if sometimes I'm bending like if I'm doing not bending a full bend here, that I might be doing a partial bend and leaving some material. Well, in order to make that happen, I may have this relief kind of cut into it. It looks like I have some control over what those relief cuts are. Uh, I mean, it's pulling the relief shape, but from my sheet metal default. So I believe when you set your sheet metal defaults, a lot of this is what you're programming in your sheet metal defaults to go along with your material thickness. So like right now, it's like got a default shape, which looks to be this rectangular cut with these dimensions that I could adjust. I would likely adjust them here and almost program this in order to program this based off what thickness I'm bending. But I can override that by saying, actually, I just want that to tear, this kind of shows that, if I have this where I'm bending some area, but I'm not bending across here, then I'm going to do no relief and just let the machine like bend through here or tear through it. There still might be a relief cut in here, but it's maybe not going to be this big rectangular cut. It might just be like a simple, like real slit, like just a real narrow, uh, yeah. And then what else do I have? Maybe a narrow slit that allows that to bend, but not bend right here. Okay, here's a round profile. So this big round, but then I terminate, instead of having a nice square with these squares with corner terminations, kind of round those off. It's going to be some strategy involved. Why I think about this is when things bend, sometimes I can prevent like the creep of a crack from happening if I radius the end of those rather than leave a nice square, like a square slot cut maybe can still like tear out at a corner and yeah, so just a quick little. And then let's see here. And then there's like the straight cut, which really resembles the default. I think these are about the same. So I know it's hard to understand what we're doing here until we get a few more bends on here, but I'm just going to leave it as the default. So it's going to put this relief cut in here. And now I'm gonna go down to corner details. And I think I'm just going to leave this thing. So really this is kind of to me the imagery shows it's like where things are bending and then things aren't bending, even though the bend where it's happening is kind of in alignment with material that's not bending. And so I get this relief, like get away from my bend so it doesn't affect unbent material. That's kind of what that relief is. That's this bend relief that I have, this relief shape. The corner default's a little bit different. It's kind of like a relief, though, of its own. It's like when two flanges come together and have bend to bend coming over. Do I need to kind of create a relief of material removed to allow these bends to come together? And, different companies can do different things and they can decide, sometimes welded joints, if the material's thick, 0.12, this thickness is 0.12, it's very weldable. So in some cases where welding is happening, they don't always love to have these big reliefs and they have to fill it in with filler metal. So sometimes they like it just to tear, or they like a really small relief there. So they don't have to refill in something that's a welded joint. But this can vary. So I don't know, like it'll have similar, oh yeah, I have a lot of options on And some of them are related to welding. That's interesting. I kind of had forgot this, but yeah, some of this does affect my weld ability. Whether it's going to be a linear weld, laser weld. That's probably a newer added one for sure. That's cool. So I'm just doing trim, which has this big cut out of it. If I did a round one, it's kind of like, well, I'm going to relieve those where they come together with um, this big round relief. Here's a square, which kind of seems like it's the same as what the default is. Actually, the default says it's trim to bend. So that's kind of and then here's tears if I didn't want any relief and I just want maybe but it can be, I mean, it can tear just like it says it tear. I could propagate, you know, these two without a relief I could cause some tearing that I don't want, or I could cause some additional stress on my machine without a relief there. And so, yeah, this stuff matters. I think I'm just going to leave it default, which puts a big old cut in it. And when we build some other stuff, we might I think I decided it was default trim to bend. Yeah. The gap size, I guess that's maybe how I would adjust some of this is like adjusting the gap size. Gap size is it's weird that some of these being auto-populated in these dialog boxes, I know are pulling from this sheet metal default setup. And so gap size is one that you can set. And so gap size it seems weird, but that's a you could set a parameter in here. We'll get into that, but I just wanted to get in the weeds a little bit. So I'm really not doing any major changes other than I just, I kind of followed what he did here in his video, just a few little changes. Definitely the same size and degrees, and I'm just going to leave everything else and say okay, and there's that bend. So you're like, well, that's great, but it doesn't even some of that tear and relief doesn't even impact it until now, until I add another bend. And what he does is, and that becomes just in order to modify that, it's just another feature like in any other part. I would have this as a flanged feature that I can get back into that same dialog box and make some adjustments. So it's not one and done. It's totally, I can go into it. What I can go into here, edit bends. Oh, I guess it's going to give me like almost I think that's the same. I think that's the same. Really gets me into the same. I really can't do anything else. Edit corners. There are no available corner reliefs to edit. Okay, so cool. I mean, I can get into these if there is a corner going on, but so the next thing he does is add another flange to this particular edge, kind of the one, and it'll automatically kind of, I think, load the last one that you did. And so it's already loading this. Hey, this is another 2-inch flange, and that's what he does. He keeps that, and if it helps, like I can collapse these and work them down, but I generally just leave them open and work them top down. 2-inch flange. I think he keeps it the same. The angle though changes to 90. And then all else, I think, stays the same. And there you start to see some of that relief just be automatically added because that's just the way it's programmed. It's like, oh, I got to add a relief in this corner situation. If I don't want this is what I mean, it does remove material and it can remove a substantial amount of material that maybe I don't want to remove. It is made to be a relief, so I don't get any like extra stress on my material or my machine to bend. And so I think everything else he leaves the same. He doesn't even change any of this. His may not show this though. Like I feel like the program has been updated and the selections in flange have really evolved over time to be pretty extensive and can make it additionally hard uh, to kind of get down and dirty with what how do I want this finish to look. Let me do another one. Um, so the next one he does, that's it. And then he does one more flange, kind of the opposite direction, which it does then kind of put the relief in this other piece here. And that may not be what I want, but I don't think he changes anything. He just leaves it at 90 and 2, I think. And the part ends up looking like this. I'm just gonna do one thing. I'm gonna select a different edge maybe. So maybe I'll just cancel that flange real quick. Just kind of interested in what it does when I overlap two together. It kind of does a similar relief, and I think I can get in here and modify that and either have it not do it or do it. And then see this becomes kind of a welded joint. Yeah. I think if we get rid of some of our gap size dimensions or put the gap size to 0, I can drive these two parts almost like so they lay perfectly align and I'm not like creating this kind of quite a large gap in materials here. Like welders don't love, they like, I mean, there are, if gapped for a reason, yes. Gapped if I don't need to, no. And so, They would maybe prefer if this is going to be a welded joint that these I drive this edge together with this other edge and cause a really nice, what I call an outside corner joint, right? That all I have to do is put some material in and fill up there's a nice kind of natural resting place for a weld to sit. But when I create this gap, that's not ideal, especially on sheet metal thin parts. No, no, no. Like gaps in thicker parts are okay and designed that way. Gaps in sheet metal are generally not wanted by a welder. So anyway, let's cancel this because I don't, well, if I select this, if I unselect that, that'll help me. And then I'm going to select this one. There we go. Just unselect that. And I can select the actual proper edge. I'll just leave the default. The default reliefs for this project will work just great. They look like that. That's his finished part, really. It's just kind of some bizarre bent part. And my reliefs are probably different than he has because maybe his program, the year that he was running, didn't even have the options that I have now and some of the control I have over that. So we have to kind of get in the weeds on our real parts, on some real assemblies that we'll do in the future. But the other thing that I pointed out that he doesn't point out either is that, from that, yeah, and then now I get a lot of things, and I can actually do some adjustment on this, even beyond just what I can take care of in the flange. Like I do have some modify commands that we'll dive into, and I can actually add material back in places where I might not want it removed. But he jumps right to create a flat pattern, which is what we're trying to do. I think of this as my bent shape, and I can go to a flat profile shape. Normally, and what I explained in class, and this kind of will bonus add on because he doesn't talk about it, but defining a side really sets a preference for what I think of as like the finished part side. So this you have to know design intent. You have to know what the design intent beyond a sheet metal part is, so that I can kind of define an A side. What it does is when we move sheet metal around to put it on laser tables and plasma tables to cut it. There can be some damage to the sheet, especially as you lay a sheet against the laser table. There's going to be a side against some fingers in the laser table, and if you slide it around, you can scratch the part. Some materials are more prone to scratching than others, and scratching of parts can be really detrimental in some really high critical areas. So to define an A side, I mean I use the analogy of like a cyber truck that has a lot of bent. I mean all it is just stainless steel that's bent for it's not overly, it doesn't, I mean, yeah, it doesn't have like these nice free flowing. It's like a Mars rover that's really square, boxy bends. And so, but they have a finished side to them, right? The panels that are made out of stainless for the outside of the vehicle, uh, I could prioritize the panel side that's going to be out, the exterior. Um, and so if I choose an A side, I'm kind of knowing the part's intent and I can choose the A side. And generally machines, if you've established an A side, will recognize the A side is up in the machine, meaning that it's not the side that's been laid down against the laser table or the plasma table that's holding the sheet while the laser is cutting it. Yeah, even like if we load materials into our Glowforge laser, one side of that material is resting against kind of this rough surface where things have been cut and sharp and uh and so anyway, he doesn't define an A side. If you define an A side, what it is like, oh, this side's out on my part. It's actually maybe I say this side is the outmost part, some kind of a fender or something. Then I would say define the A side. Yep, this side's going to be outside. It doesn't notice anything happen, but it did establish that in your browser tree that is now my A side. When I select it over there, I can see, and the machine's going to interpret this as being the side that they want to have facing up against the laser and cut it this way. And maybe some sheets that are like stainless steel generally comes coated. Some stainless does. Maybe you have to pay for the upgrade cost, but they can already put some plastic coating on this, which the lasers can just cut through easy. And so you don't have to remove it to cut it, but it's a protective layer against scratches. So anyway, sheet metal comes. Aluminum's really prone to scratching, right? It's a really soft material. Generally, the little fingers that are holding up materials on laser tables, plasma tables. Maybe it's just like a mild steel. Sometimes they're painted, but they just they contact the steel, not completely, but sometimes they're just jagged little points that hold up the steel. And so they get cut up over time too, like the laser cuts across them and the plasma tables cut across them. And they're generally like sacrificial pieces in the laser table. They can pull them out and replace them. You could probably stack them with materials like It's not good to scratch stainless steel with mild steel. It'll make it rust. And there's all these rules. Oh my gosh. So much to learn about materials, and material handling is a real deal. So I've defined an A side. You don't have to. And then when I unfold this, it'll drive that side is up. So I'll go ahead and delete this A side designation, delete it. And if you don't define it, which maybe was an add-on, I think it's in his book. It shows A side. I just don't know in his videos if he's using a program that had that. I don't know when they added that on, but and maybe it's been there forever. I can't remember. But if you don't pick a A side, it's going to pick an A side for you. So I'm going to go over to the create flat pattern right here. And then there's what it would be if it was laid out flat. So now this can become a cut file is what I call this. Like this is the flat profile, and maybe I put it on a cut file sheet, and and I think I do that on my I think I did that in my video, so I'll try to do that real quick, but kind of running out of time. Anyway, this is the flat pattern as if it was all laid out. And so what I'm looking at here that are automatically applied is this is kind of the center of bend, kind of where my machine's going to come down and hit that center mark and bend it. These dotted lines are the bend extents. So that's kind of the parts that are going to be, compressed and stretched in that bending when that happens. So it's kind of bend extents and center of bend. Just automatically applies those. So, my bend isn't here. It's actually right here. This relief is to relieve around those bends and allow material. But I could definitely change my profile on how this is bent and maybe put the bend relief in the same part or minimize the bend relief if it's to me it looks very obtuse here. I feel like it's way excessive on the bend reliefs, but just leave it its default. And I can go right back to folded part. You'll notice it's kind of like a model browser in a Weldment or whatever. You don't have access to the original modeling. You're into a flat pattern, which is it appears under the end of folded over here on your model space. So you can only like manipulate stuff in the flat pattern while you're in the flat pattern. If you go to folded part here, you're back into the normal model browser where you can change some things, and the flat pattern will automatically update. Some things you would change up here can cause your flat pattern to blow up, and it can be hard to recover it without deleting it. And then if you delete the flat pattern, you delete the flat. If you delete the flat pattern, you might delete the cut file that's associated with it. So this can kind of domino effect on you if you start changing the design a lot, and the flat pattern just can't keep up with those changes without establishing a new flat pattern. But if I go back to that flat pattern right here, it's been established. The other thing he shows you is this will give you like a simulated like bend sequence order, and that matters. Like I have to know how to bend these. Uh, in some parts it wouldn't matter, and even if this machine thinks you should, or if the inventor thinks you should bend it in this sequence, generally this is going to be a decision made by, I mean, the equipment also knows. Like if this model can go to modern equipment and this might tell the equipment this is the sequence I need to bend, and if it's a robot that changes out dies for this, it would do this in accordance with what these bend lengths are and how it's going to fit in the machine. But things get a little complicated on bending sequence, just like welding sequences matter. Yeah, so that's just one option that you see, and then this machine says bend this one first, bend that one second, and then bend this one third. So it doesn't necessarily mean that has to be the way it's going to be done, but it's suggested. So I would save this part as my I think I'm finally into week 5. I've been starting to save stuff, but this is my exercise part 1. I'm going to call this in class because I lost my original recording. So in class, go ahead and say save. So there is my bent part. I'm just ready to put this on a drawing, and we didn't even do he doesn't do any eye properties or everything. He does just show you something that I want to show you too. So I'm going to open up I'll go ahead and open up a template drawing that's inch templates. This has also been updated, so pull it from Canvas if you haven't for a while. Pull a new one. I've got some more ASME updates in this. But here's my drawing sheet for B size. And now I'll go ahead and save this too. Sorry, let me drop that. I always move these around, but let me go ahead and save this as my drawing for this assignment in week 5. It's going to be this one. I'll just call it in class though. So I'll save that. And so I have a new drawing sheet to start with. here's my part that I'm putting on it. What I want to show you different, I'm going to look at it real quick, jump over here and just go place the base view. It's the only thing I have open, so it's all that will. So it's going to show up right here in its folded form. Um, and you know, I'm ready to do the orthographic projection views on this. But what I want to show you is now that I have a flat pattern, a sheet metal part, I can change which view of this part I'm showing. I actually pick flat pattern, and that is the flat pattern that's associated with this, which is going to become a cut file. It's going to become a DXF file. It's going to become just a 2D drawing file for a machine to interpret, and then we're going to bend it in with a press brake to bend it into its form. So that's what a flat pattern is. And so I'm just going to go to the folded model. Maybe I'll say that I'm going to make this at a half scale. Good. It actually sized down for me. I'll add the view label, but like in order to dimension it out in a normal drafting, we'd probably have to have a front right side view and an isometric of this, right? We'd probably have to have that. And uh and so in class, I think I just dropped these on. I'm not dimensioning them or really doing much else with them. But and I would leave the hidden lines on. I'd go to town dimensioning this out now. And then what I showed is that, and I think he shows it. He does it on two different sheets and deletes one or whatever. I'm just going to say, you know, you could drop that on there. And then I can drop a flat pattern here too. Normally my flat patterns end up on their own cut file sheets, maybe organized by material thicknesses and types. I might have multiple sheets with different materials of parts being cut, and I would want those to be their flat patterns. So I'm going to put this on the same sheet, but a lot of times these end up on separate sheets, cut files, and that's what I figure. That's what I say is a flat pattern is a cut file. So if I place that again, I'm going to say the same base view. Here's my part again. I'm just going to say the flat pattern, and he shows this in his video. And I would still have a view label potentially for this on a cut file sheet. I would want to have the part number with it, you know. And flat patterns, I definitely don't do hidden lines at all. So I want to make sure I'm not doing hidden lines on my flat patterns. And I've selected flat pattern, and I'm going to say OK. And he shows that he pulls different views of the flat patterns, but in actuality, a flat pattern like this is just going to be for machine interpreting, machine to cut. On our laser would cut this too. If I just would send just this file over to it, it would cut it out with that profile out of whatever thickness I put on the machine. And oh yeah, what I wanted to show you is when you place this on here, generally the way you would like dimension out a cut file or is still that because these cut file sheets end up kind of disassociated from the drawing packet. They're in the drawing packet, but maybe the person in prefab that's like handling the machine cut parts, loading the materials and stuff, they might lose track. I mean, they're cutting like sometimes when they nest this, they would nest multiple jobs on the same sheet. And so they can identify the parts, but you can help them identify the parts because maybe they don't have the whole print pack. They're not the ones building the equipment. They're just the ones cutting the parts. And so they're just looking at cut file sheets a lot. So it helps them to have the part identification. They can even choose on a laser to etch that part number on the part. And they could even just steal your part number description here and like throw it on here, size it down, and have that thing etched on there. But I can also add some more information that they would want to know and that prefab I think would want to know, which is they want to know some dimensions so that when I grab this thing off the table or I throw it on a pallet of parts, I might need to be able to quickly, so I'll put this out at the 0.375 spacing. They might want to know what the overall part size is. They can throw a quick tape measure on it, identify, hey, that's 8.95 and it measures by this. I'm going to reference that real quick, and then as I step away, that 3/8 spacing will be 3/8 from that last reference line that I just hovered over for just a second. And so now these are 3/8 spaced. Let's see. Yeah, I can quick. So that's all. Like on a cut file sheet, that might be all they need to know. Just a quick part identification dimension. And then we have this, and so this is above and beyond what the chapter shows, but on my annotate tab, I have this where I pick when I have a counterbore on that last job. We use this to identify it and notate it really fast. Bends, the prefab people that are running the bends, if it's manually ran or whatever, or human ran, not robot maybe, but they would want to know like this bend. I could choose this bend note, it's bend notes, and then I can choose this. This is actually, if I zoom way in here, it's just the center line. And I can choose this of bend, and it actually already notates that, hey, bend that down 60 degrees. And the radius is going to be 0.12, which I think matches the material thickness by default. And then I could choose this one, bend that down 90. And then this one probably should be a bend up 90 degrees with the same radius as all of them. So these can be added. These are really helpful for people that are going to handle this. This maybe doesn't become part of the part. These can be etched in the part though, but maybe they just need to be able to reference this drawing and this flat pattern sheet on a cut file sheet to know how to bend that and then put it on a pallet and deliver it to some welder that's going to have to learn how to assemble it. So everybody in the system has a different need for different prints. And so you have to kind of cater to those needs, especially when you're working for a company that has in-house engineering drafting and in-house manufacturing. Um, you're kind of preparing prints for machinists, for material preppers, for prefabrication technicians, and for welding technicians. Uh, and so yeah, your prints have to incorporate everybody's needs essentially. I just put these two on here, and that's the only dimensioning I did on mine. I said I saved it as this job, and that's it for this lesson, you guys. So let's see how long it was. I think in class it was about a half hour, 33 minutes. Let's see, I'm probably longer.